Hi everyone. This is a video about triangle congruence. So the fundamental question for us today is, what information uniquely identifies a triangle? And the reason we're interested in that is that if we know a set of information uniquely identifies a triangle, then we know that if two triangles share that information, then those two triangles must be congruent. So for example, here is a triangle that has two known side lengths. This is the length AB and this is the length CD. It's been constructed like that. Does this determine a unique triangle? Well, we can move this around and we can see if we add the third side in that we can make all kinds of different triangles with those two side lengths. And so side does not determine congruence for triangles. Similarly, side angle does not determine congruence of two triangles, because there are lots of different triangles you could make with a given side and a given angle. So we could put a point on that ray, and so this angle is congruent to this angle, this side is congruent to this side, but you can make lots of different triangles with that side and that angle. So side angle is not a condition that would guarantee triangle congruence either. Now, as we discussed in class, side is a congruence condition because you can only make one triangle up to congruence that has those three given side lengths. So we can move this around, we can rotate it and translate it, but we can't fundamentally change the size or the shape of this triangle. We could also reflect it over here, right, if we constructed that point. But side is a congruence condition for two triangles because only one triangle can be constructed with that set of information. Likewise, side is a congruence condition because if we construct a triangle, or if we construct something that has this side and this angle between them, then that really makes only one triangle. Again, we can rotate it around, but there's only one, up to congruence, only one triangle that has those features. So side is a congruence condition, as is angle. So here we have two angles and a side between them. And notice that regardless of what those angles are, there's going to be a unique place where those angles intersect right there, and that is going to determine a unique triangle. And so angle is also a congruence theorem, or congruence condition. Now the last situation is side angle. So we have a side and an angle, and we have another side, but the angle's not between the two sides. So that other side is going to be over here on this circle. So this is the side angle situation. Now notice that I could put the point here, and this would give us a triangle that has these two sides and this angle. I could also put the point there, and that would give us a different triangle that has these two sides and that angle. And so side angle is not a congruence condition because you could get these two triangles, this one and this one. Now it's interesting because side is not a congruence condition because you can get infinitely many triangles, just like side angle, you can get infinitely many triangles. Side angle, you can get two triangles, which is kind of weird. But what's even stranger is sometimes you can get a different number of triangles in the side angle situation. So that's something we're thinking about. Under what conditions might you get a different number than two possible triangles under the side angle condition?